Dear friends, in this video, we are going to see fifth unit operating system. In this unit, we will see what are the important topics and important questions for the uh, end semester exam. Let us start our discussion. Fifth unit is about deadlock. Look at the syllabus here. We see the system model and deadlock characterization. What are the methods to handle the deadlocks and deadlock prevention and avoidance? And then detection and recovery. These are the things in the 15 unit. 15 unit is very small and easy to score. It is easy to prepare. So these are the topics: deadlocks, characterization, handling, prevention, avoidance, and recovery. See in this diagram, it is a diagram of deadlock. See, vehicles are coming from this side, coming from this side, coming from this side, and coming from this side. So all the ways are blocked here. So there is no movement of vehicles, right? There is no movement of vehicles. This is called deadlock because there is no coordination among the vehicles. It created a deadlock. So we need to avoid such kind of problem. So it is loss for all the vehicles, right? It is loss for everybody who is driving in the vehicle there. What is a deadlock? Deadlock is a situation where one person is waiting for another infinitely. One person is waiting for another infinitely. In operating system, a process is waiting for another process infinitely. Okay. Waiting for some time is not a problem. Waiting infinitely is a problem. Waiting infinitely is a problem, right? Deadlock is a situation in which every process is set up waiting for some event that can only by the another process in the system. Next, if there is any resource, we want to use any resource in the system, three things to remember. One is first you need to request this resource. Suppose the resource is like a printer. If I say printer, first you request the printer. If it is available, then use it. After using that printer, release that one so that it is useful for other others in the system, right? Next, this is the system model. There are some processes, some resources. Resources means system resources, memory, CPU, IO devices, and request and release. First you request, use, and then release. Hold and wait. Suppose if you want the two, if you want the printer and the scanner, both of them, then you hold one printer and wait for scanner. Circular waiting. Circular waiting means A is waiting for B, B is waiting for C, again C is waiting for A. This is circular waiting. This is a lock here. Circular waiting. Next, characterization. This is very important. This is very important. You remember, you have to by heart this question for the exam point of view, right? There are four conditions for deadlock to happen. All these four conditions should hold simultaneously. All conditions simultaneously at the same time happens. If these four conditions happening at the same time in the system, then there is a possibility of deadlock. If three conditions are satisfied and one condition is not satisfied, then there is no deadlock. Let- For deadlock to happen, these four conditions must be happen. Mutual exclusion and hold and wait, no preemption, circular wait. Mutual exclusion means only one person should use at a time. Only one person should use a resource at a time. Suppose there is a printer, only one person use at a time. Okay. Hold and wait. Hold and wait means if you need printer and scanner, hold one and waiting for another. Holding the printer and waiting for scanner, it is called hold and wait. Holding one resource and waiting for another resource. No preemption. In the system, uh, no preemption means resources cannot be preempted. Preemption means taking away from somebody else, taking from somebody else. When somebody using the printer, somebody is printing some pages, 100 pages. So he completed 50 pages. You want the printer and you have taken the printer from him. That is preemption. Repeating and somebody is printing. He need to print 100 pages, 50 pages he already printed, and you want the printer, you took the printer in the middle. So that is called preemption. That is called preemption. And circular wait. I told you right already. Suppose A is a process waiting for B and B is waiting for C, B is waiting for C, again C is waiting for A. If these four conditions happen at the same time, four conditions at the same time, that is called simultaneously, then there is a possibility of deadlock. There is a possibility of deadlock. If only three conditions are there, then there is no deadlock. Methods for handling the deadlock. What are the methods we have for the handling of deadlock? See here, first one, deadlock prevention. In prevention, what we do? Design is in such a way that at least one of the deadlock conditions not occur. We have to make sure that at least one of these four conditions, one of these four conditions should not happen. We should make sure that one of these four conditions should not happen. We should make sure that one of these four conditions should not happen. Why at least one we are targeting? Because for deadlock to happen, these four conditions must be happened simultaneously. If there is only three conditions satisfied, means that there is no deadlock. So we will try in the system that at least one of these conditions should not occur. Deadlock avoidance. See here, avoidance. Make the decisions on the resource based on the resource availability. Availability of the resource, we should make the decisions. This this will avoid the possibility of deadlock. Means we should make the decisions according to the availability of the resources. This is not possible always because we don't know exactly in the beginning how many resources are available for how many processes. So we this is a theoretical concept. We try in our systems. This is to avoid. But we need to have the foreknowledge, future knowledge, what happens in the future. So that is not possible. We cannot foretell everything what will be happen in the future, right? It depends on the future knowledge. And here deadlock detection and recovery. Suppose you allow the deadlock to occur. Four conditions satisfied, four conditions of the deadlock satisfied, and you allowed it. So occurred. Deadlock occurred in the system. Deadlock means in the beginning you have seen, right? This is the deadlock. Deadlock happened. This diagram is the deadlock. Deadlock happened. Now what to do? You detect the deadlock first, and uh, we need to recover. Suppose you got some disease and take the medicines. You got some disease and take the medicines. Periodically check for deadlock extent. For every few minutes, we need to check whether there is a deadlock or not. Okay. If you find the deadlock, if you find the deadlock, so we need to use some recovery mechanisms. We need to use some recovery mechanisms for resolving the deadlock. Okay. So deadlock prevention. How do you prevent the deadlock? How do you prevent the deadlock? Here, first condition, you see, you make uh, some resources shareable. In the previous four conditions, all are non-shareable mode. Okay. Here, he it is saying to make some resources are shareable and some are non-shareable. Right? Hold and wait. Must request all the resources before starting of the execution. So if you want to work, you start the work only when you get the resources. That is the idea. No preemption. And resources can be preempted from a process if necessary. We are allowing. So in this we may like to the other like starvation, right? Circular weight avoidance. We need to avoid this also, right? We will follow some ordering of resources. Each process must request the resource in some order. Suppose if we have a printer, scanner, we will order the items. Like a printer, we give the order one, and scanner, we give the order two. Suppose if you have the printer, then only you can order the scanner. If you don't have, suppose if you have scanner in your hands, then you cannot order the printer, because the ordering is important here. If we say the order. So deadlock avoidance. As I already told, we need to calculate the resource need of the resource, availability of the resource. If we are satisfied with our need, then only we can proceed. So we have here one banker's algorithm for solving this problem, deadlock avoidance, and also resource allocation graph. Second one is resource allocation graph. Resource allocation graph is a graph set of vertices and set of edges. Set of vertices and set of edges, right? Here R1, R2, R1, R1, R2, and so on are the resources. And T1, T2, we are calling as threads. Calling them as threads, right? Resource allocation graph. See here, we create this graph. We already seen in the class with the resource and with the, if you see one dot here, here it is, there is only one dot, means one resource of type. Suppose if it is a printer, only one printer available. Suppose R2 is a scanner. How many dots are there? Two dots. Two dots means two resources. Two scanners are available, like that. So number of dots means number of instances availability. In this graph, if you find any cycle, then there is a chance for deadlock. If there is no cycle, no deadlock. Simple formula. If there is any cycle in the graph, then there is a possibility uh, that there is a deadlock. If no cycle means no deadlock. See here, is there any cycle? There is no cycle in the diagram. Figure 1. Second one, you look at second one. Is there any cycle here? Is there any cycle here? So you try for some cycle. So there is a cycle here. So if cycle means, then there is a possibility for deadlock. Okay. Deadlock detection and recovery. Deadlock termination. Process termination. So we if three are more uh, processes processes are in the contention in the competition. If you kill one process, then there is a chance to remove the deadlock. There is a chance to remove the deadlock. So remove one process from the uh, competition, then there is a chance that it may remove the deadlock. Resource preemption. Preempt resource from, suppose somebody is using the resource continuously for hours and hours, then we can remove from him and we give to the somebody else. Okay. So this is all about the unit 5. So look at the definition for deadlock. Deadlock is infinite waiting, and these 4 conditions also important. And what are the 3 methods here? What are the 3 methods for handling prevention, deadlock avoidance, and deadlock detection and recovery? So resource allocation graph also, you remember. This is very small, easy to score from this unit.